Okay. Without a lid is to have a volume of 10 cubic meters. The length of this base is twice the width. Material for the base cost, I think we did this problem last time. Material for the sides cost 9. I think we did this problem last time, but maybe I'm wrong. Find the cost in dollars of material for the least expensive. Minimize cost. Now I have to check my memory. When you get to my age, you'll do the same all the time. You're going to check your memory. Voila.
Oh, okay. My bad, yeah.
No problem. No problem. Good. Anything else? Anything else?
Could we get an example of Newton's method?
Yes.
Yes, that's what I was going to say.
Perfect. Excellent. So can anyone give us an equation? Or if not, I'll open the book. I don't know if you can see. What is the problem we think with Newton's method? I mean, there's just creating a function and plugging in. Which part it's not clear overall?
For me, it wasn't anything in particular. I just thought it would be useful to see it demonstrated again.
Okay. Okay, we had like 2 or 3 problems last time. Let's choose another. Anyone? Okay, I'll choose 17. 3 cosine x equals x plus 1. So 3 cosine x equals x plus 1. First, I have to create the function. So this is 3 cosine x minus 1. Solving this equation or solving this, it doesn't make any difference. But we want to have a function to talk about. And also its derivative right away. I mean, minus 3 sine x. I think I did this problem, exactly this problem last time. And please, for more examples, watch the videos, because we did I think we did this problem last time. I'm not going to check my memory on this one, but I'm pretty sure. Okay, so here we have to find, first of all, we have to write that f is continuous everywhere, but I have to find an interval, and then I have to find or show that it's positive at one end and it's negative at the other. And it has to be a 1-unit interval. So I plug in the function, and that is 3 cosine x and minus x minus 1. Oops, not that minus. Minus x minus 1. And with second and table, I'll start slow, like 0 and then 1 and then 2. Or I go to negative 2 and negative 1. And that's it. Between negative 2 and negative 1, there is a solution. At negative 2, the function is negative, and at 1, the function is positive. By the intermediate value theorem, there must be a solution between negative 2 and 1. So from here, there is a c in the interval negative 2, comma 1, such that f of c is 0. At this point, I determine the function, or I create the function that I'm going to use. And the function I'm going to use, I like to call it Newton's function. It's x minus the function at the top, 3 cosine x minus 1, and the derivative at the bottom. I have to make sure that I start with an x sub naught or x0 that does not make this function 0, because then the method will never converge. It's undefined. The function will be undefined. So I can start at -2 or I can start at 1. So 1 meaning 1 radian. So this is not 0. So when I start at that, then I'll find x1 and then I'll find x2. And I'm just going to write x1 depending on how many decimal digits they want. So I go back to y equals. I insert x, subtract, put parentheses, insert x, subtract, put parentheses around the function that I already had, and divide by the derivative. In parentheses, -3 sine x, close the parenthesis and -1. And then I go to second and table. I don't need to do that. I just need to go ahead directly to variables, y1. I plug in 1. And this is my first iteration. And when I copy, I just write the previous answer. And from this moment on, I will get the solution with as many digits as I want. Okay? Is that good enough?
Can you go back one more time on the calculator?
Yes?
I got it. Yeah, I've already got it in my y equals.
Okay. So then go to variables, y variable, call the function, in parentheses 1. And this is your first x1, the first iteration, 8, 9, 2, 4, 3, 7, 9, 5. And when you copy the previous entry, then you just overwrite the 1 with the previous answer. And this will stay forever, meaning if I do the same thing again, it will enter this answer. And then it will enter the next answer. And so on and so forth. Is that okay?
Yeah, my numbers just came off different. I think I must have just put my equation in wrong.
Yes, that's very important. So x minus, left parenthesis, 3 cosine x minus 1.
Yep, that's it.
Close the parenthesis, divide by, and now in parentheses, open up another. You start with this negative, right? -3 sine x, close the parenthesis, and -1 and close the parenthesis. Yeah, you need parentheses around the denominator and parentheses around the numerator. And now when you go to variables and you plug in 1, you will get 0.8924375. Is that okay?
Yep.
Perfect. Did you get it?
Yes.
And then when you just copy, this is the first time and the last time you need to do this, just enter the previous answer. So the calculator now takes the whole answer, not truncated. If you type it in, it will be truncated. The calculator takes everything it has and puts it in. And the method will converge slightly faster or faster, and you will get a better answer. Okay? If you actually want to stop at 5 decimal digits, then it converged in 2 steps after x naught. Very good. Okay, so we are moving on and finishing up chapter 4 with 4.9, which is not part of this test. It will be part of test 4, antiderivatives. What is all about? What is this all about? Well, we can be given the derivative, or we can be given a function. If I'm given a derivative, I will be asked to find the function. And the notation here is very important moving forward. So I'm given the derivative and I'm asked to find the original function whose derivative is this, whatever I'm given. Second option, I may be given a function and I may be asked to find its antiderivative. Same idea, but this time we're going to denote it by uppercase f of x. So if I'm given f of x, I'm asked to find the antiderivative, which must be denoted by uppercase f of x. If I'm given g, then this will be uppercase g. If I'm given t, lowercase t, this will be uppercase t, of course. But if I'm given a derivative, I'm asked to find the function.
So, question about that further notation and
Yes.
what the sign. Normally, it'll give us like, hey, find the derivative of capital F of X.
We're not
Like, will it
talking
be
about-
lowercase then?
We're not, so you're talking about this?
Yeah, because WebAssign has weird notation sometimes. Sometimes it'll be like, find capital F of X, like the derivative.
I doubt. You have to show me that.
Okay. I'll find an example and just send it to you.
Yeah, please do, because this WebAssign is based entirely on the book.
Like, the notation in WebAssign just gets a little weird sometimes, so that's why I was just
It
wondering.
is possible, but please indicate which one so I know. Please, thank you.
Okay.
Okay?
Yes.
Thank you so much. It really helps me if I know where you found that. Okay, so one more time, if I'm given the derivative, we're asked to find the function. I may be given the second derivative, and I may be asked to find the function, but first I have to find the first derivative and then the function. I have to. Or I may be given a function, any function, and find its antiderivative, and then the notation would be uppercase f. Okay. Before we attempt this, obviously, if I say f prime of x is cosine x, and I'm asking you to find f of x, what will you say? You have to say sine x, but you also have to say plus a constant c. And this is a family of functions, all of them having f prime of x cosine x. If I differentiate this function, sine x will be cosine x. If I differentiate the constant, I get 0. Okay, let's see how the power rule works, and then we can choose problems to practice. So whenever we want to have an answer, let's say, of x cubed, what will I differentiate to get x cubed? The answer must be x to the 4 over 4. I increase the power by 1 and I divide by that number. How come? Because when I differentiate, I bring 4 down, which simplifies with 4, and I get x cubed. So if I want to find any x to the nth power, the answer would be, the function that I need to differentiate will be x to n plus 1 over n plus 1 in general. Having said all this, let's take a look at different situations. And I'd like to start with, we are given the acceleration, which is 3 cosine t minus 2 sine t. We are given that the distance at 0 is 0. We are also given that the velocity at 0 is 4. The question here is, find s of t. So given the formula for the acceleration, and given what we call conditions, initial conditions, we are told that s of 0 is 0 and v of 0 is 4. We're asked to find v of t. we're not asked to find the family of functions. I wanted to hold on to that, but I'm going to put the name here, which is the most general. There is a space between the and most, of course. The most general antiderivative. Here we determine the most general antiderivative, or the most general function. Whose derivative is that? Okay. So here we're not asked to find the most general. Why? Because we are given two conditions. Okay. From the acceleration, I cannot jump to the formula for the distance directly. I have to find the velocity. Okay. So knowing that the velocity is the antiderivative of this, I have to find the function whose derivative is this, so that this is 3 sine t. Now I have to find the function whose derivative is this, so this will be plus 2 cosine t, and plus a constant that I will call c1. Let's stop for a moment and check if we need to. 3 sine prime is 3 cosine, yes. Positive 2 cosine prime, yes, is negative 2 sine t, and c1 prime is 0. At this point, I will use this information because I really want to determine c1. I know that v of 0 is 4. So when I plug in 0 for t here, I get 0. When I plug in 0 here for t, I get 1 times 2. So 2 plus c1 equals 4. Therefore, c1 equals 2. So v of t is 2 plus c1, and we are told it equals 4, so c1 is 2. I have the only function that is the velocity, not a family of functions, that fulfills the given conditions. But my target is the distance formula, or the distance function. Fine. So the antiderivative of the velocity, which will be s of t, is the function whose derivative is this. Which function prime is 3 sine t? Well, that has to be negative 3 cosine t. When I differentiate this, I get that. Now plus 2 sine t. Why? When I differentiate 2 sine t, I get 2 cosine t. Plus, which function prime I get is 2? Well, it must be 2t. And plus a constant that I will call c2, not to be confused with c1. Let's check again. This prime is that, this prime is that, this prime is that, this prime is 0. I do have one more piece of information. I am told that s of 0 is 0. When I plug in 0 here, it's 1, so I have negative 3. When I plug in 0 here, it's gone. When I plug in 0 here, it's gone. Plus c2 equals 0, which makes c2 equals 3. So I found the unique function, distance formula, or distance function, that complies with the given conditions. The only function, the unique function that complies with those conditions. So this is s of t equals negative 3 cosine t plus 2 sine t plus 2t plus 3. And there is no other function that fulfills the given conditions. Okay, let's look at another one. Let's say the second derivative equals 4 plus 6x plus 24x squared. I'm given two initial conditions. The question is, find f of x. Okay, so in order to determine f of x, I have to find f prime first. which function prime is 4? That's easy. Must be 4x plus 6. Which function prime is x? Well, I have to increase the power by 1 and divide by that exact number. Plus 24. Which function prime is x squared? I have to increase the power by 1 and divide by that exact number. Plus c1. So let's check again. This prime is this prime is this prime is this, c prime is 0. I do not have any information about f prime. I have to continue. So I'm going to continue to f of x. Maybe I should have simplified here and get a 3, simplified here and get an 8. Okay, so 4. Which function prime is x? Well, x squared over 2 plus 3. I have x squared. X to the third over 3 plus 8. I have x to the 4th over 4 plus c1x plus c2. So let's check. This prime is 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 0. I'm going to clean it up. And for now, f of x is 2x squared plus x cubed plus 2x to the 4th plus c1x plus c2. I have 2 unknowns, 2 parameters, but I do have 2 expressions that will help me, 2 equations or 2 pieces of information that will help me determine those. I'm going to start with f of 0 is 3. 0, 0, 0, 0. C2 means that C2 is equal to 3. So I have that f of x for now is 2x squared plus x to the third plus 2x to the 4th plus c1x plus 3. This was used. Now I have to use this. When I plug in 1, 2 plus 1 plus 2 plus c1 plus 3 equals 10. 2 plus 1 plus 2 plus c1 plus 3 must equal 10. When I plugged in 1 for x, I got y value to be 10. So 3 plus 1 is 4, 4 plus 4 is 8. Subtracted from 10, c1 is 2. So the unique function is, and I'm going to put it now in the correct order, 2x to the 4th plus x to the 3rd plus 2x squared plus 2x and plus 3. This is the function whose second derivative was given to us and some initial conditions were given also. I like to find one in which conditions are not given, so we are asked to find the most general antiderivative. And then we can move on. Any questions so far? Anyone? Anyone? Okay, so let's say we have the third derivative now of t equals e to t plus t to negative 4. We're asked to find the most general antiderivative of this function. Okay. In order to find the function, I have to find the second derivative first. What function prime is e to the t? E to t. That's the nicest function possible. Plus t to negative 4 plus 1. I have to increase the power. Negative 3 divided by the exact same number plus c1. If I want to simplify a little bit, I will write e to t minus t to negative 3 over 3 plus c1. At this point, I will find f prime. What function prime is e to the t? It's e to t. And then minus 1/3 times, I increase the power by 1, t to negative 2, and I divide by the exact same number, plus c1t plus c2. Finally, finding f of t. I want to simplify it a little bit before I do look at f of t. So e to t, this will become plus 1 over 6, t to negative 2, plus c1t plus c2. Okay, and now we can write f of t, not x, now that it matters, e to t plus 1 over 6. I increase the power by 1. I divide by that number, plus c1, I increase the power by 1. I divide by that number, c2t plus c3. I will clean it up a little bit, negative 1/6. I can put t in the denominator now, plus c1 over 2 t2 plus c2t plus c3. This is the most general antiderivative. As you see, it's a family of functions. Infinite. C1 can be any real number, C2 can be any real number, C3 can be any real number. Any questions for me before we start chapter 5? Any questions?
Could we do a L'Hopital's rule?
Yes. Do you have a problem? Yes, of course.